Today I will be demonstrating the Spotlight Custom Seed Points box feature. This is very useful for images where there are a lot of clustered objects together, similar to what we can see here. Now typically, Spotlight will find these larger clusters as one single object. Let's just run a default, for example. Not exactly what we want. So we can first go about by finding these specific seed points and then running Spotlight locally on a localized area using our box method. So in order to get these seed points, we need to do some preliminary steps. This will help us create these seed points initially and get us a cleaner image to work on. So for pre-processing, we want to do a quick non-local means with a strength of 0.05. This will give us less variation within the image, thus allowing us to do local maxima calculations. So first we set this as memory image 1. Then we can go in and find local maxima at a threshold of 0. This gives us seed points within each of our objects. However, we do have some external artifacts that we definitely do not want to keep. So we go in and call our first memory image. Let's just get rid of those real quick. Under pre-processing, we can go into advanced texture, do a quick trace at a radius of 3, and then a basic threshold at a value of 75. We only want the bright spots since we will be intersecting this with our previous selection of local maximas. A quick uniform dilation and erosion should give us a little smoother of an image. And now we can quickly go in, set this as our companion, and do an intersection to only keep the local maximas. There's some external particles we still found, but we got rid of a lot of the unnecessary seed points. Now we can run Spotlight on this. So we would go in here, set this as our companion image first. And then under our use case, it will now be selected to custom since we already have a companion image. If there's a companion image present, it will default to custom. If there's not, then it will default to grid since we cannot use custom without seed points. So under the box method, we can go in, decrease our dilation to 5, which should give us a very local area to run Spotlight. This will help us break up some of these clusters. And our score filter, we will keep it at 25. So let's press perform, see what happens. Now that we have a very good declustering, we can further on go to separate these features even more. So let's go in and with some classical steps like our reject features and our separate features, we can go in with a separation of 0.01. As we can see here, gives us some more separation. And with our reject features, we can do a quick eccentricity threshold, which will help us get rid of these longer objects that we know are not features. So after this, we could go in and make sure that we save this as our memory image too. So to get rid of these darker patches, where we have some feature selection, but we know this is inaccurate, we can call our first memory image, which was our non-local mean step, and do a quick basic threshold. A value of 64 will give us a selection of the darker patches. Now, setting this as a companion, calling our secondary memory image, and doing a quick keep exclusive should get rid of those specific patches and make sure nothing that is contained within them is within our final segmentation. Now, the recipe is complete. Did a very good job. And we can have a quick count measurement for our final result.